everyone, it's Alyssa and welcome to You Can Learn Math. Today's lesson is on completing the square. This has to do with solving quadratic equations. Like if you have something like this and you're asked to solve or find the zeros of this quadratic equation. I've already done some videos on factoring and finding the zeros, all the different kinds of factoring, and if you have numbers in front of the x squared, if you have a negative in front of the x squared, multiple videos on that. If that's what you need, if you're trying to figure out how to factor this, then please look at the description below. I have those videos linked. This is very specifically about completing the square. First things first, here is our principle that we're going to be working with. Oh, and also, if you're looking for completing the square when you're talking about finding the vertex form of a quadratic, where it shows you and you have to use completing the square, that's a different thing. It does involve completing the square, but it behaves a little differently. So please go and watch that video, or watch that video after you finish this one, because they are different. They are different. There's a little difference in how you play it out. The concepts are related, but just saying. That video link is down below as well. Okay. Anyways, here is our concept that we're working from. If I have two numbers or variables, it really doesn't matter, and I have them inside parentheses and have it squared, if I did FOIL, when we say FOIL, again, link below if that doesn't sound familiar, and we're doing our FOIL and we're distributing everything, what we would get is a squared plus 2 times a times b plus b squared. Oh, that zoomed out way further than I expected it to. There we go. Okay, so let's try this with something like x plus 5 squared. Well, according to this pattern, this is my first term, or my a. This is my second term, or my b. So the pattern says that my result, I'll have 3 terms, boom, 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 and that the first one will be this term squared, so x times x is x squared. Then it will be 2 times this term times that term. 2 times x times positive 5 is positive 10x. And my last term will be this one squared. So positive 5 squared is positive 25. So if I know that pattern, I don't have to do FOIL. I can just write it out. And this is a perfect square. X plus 5 squared creates this. Completing the square is about having this knowledge and working backward from it to get from this back to x plus 5 squared. How are they connected? And we're going to need this information in order to complete the square in a minute. So if I were to look at this full thing and I didn't know where it came from, this pattern says the middle term is 2 times a times b. So I'm like, okay, I need my a and my b. All right, my first, this is a squared. So I take the square root of that, x. This middle term is 2 times a, my a or first term is x, times my b. 2 times x times what is 10x? 5. So like, okay, positive 5. Well, this last one should be 5 squared. Is it? Yes, it is. So those are the same. Now, what if it was like this? And they said, and we didn't know this, and they just said, make this a perfect square. You go, okay. Well, what perfect square could I make it? Well, this is my first term squared. So what squared equals x squared? X. Okay, so then 10x, this middle term would be 2 times my first term times my second term. 2 times x is 2x. 2x times what equals 10x? 5. Positive 5. So I'm going to write positive 5 there. Well, if this is my square, my perfect square, x plus 5 squared, then the last term needs to be this number squared. Positive 5 squared is 25. So if I add 25 to x squared plus 10x, I will have turned it into a perfect square. That is what completing the square is. That's what you're doing. So that's the math that's happening. Here's the process that you're going to do, the steps you will take. I'm a firm believer in don't just give you steps to memorize, show you what's going on first. This is what's going on. So what did we do exactly? Given that, this is a big given, and we'll see why in a second, there's no coefficient in front of the x squared. What I need to do is I take this number next to the x in the middle, I divide it by 2, which gives me a result. I take that result and I square it. And I put that number there. That's your process. So all this is what's going on. That's what we're doing. We're turning it into this square because of this pattern that happens. But the actual steps you will need to take are, again, assuming there's nothing in front of the x squared, you're going to divide this by 2, which gives you 5 in this case, and then you're going to square it, and that's your last number. So that is the process. Now, how do we use this? Here's an example. X squared plus 6x plus 8 equals 0. Now, this one could be solved by factoring, but we're going to solve it by completing the square. First thing you want to do, you want this to be on the other side. You do not want it to be here. All you want on this side are your variables with your terms with x's in them of any sort. So to do that, I'm going to subtract 8 from both sides. That gives me x squared plus 6x on the left. The 8's are canceled out, and on the right I have negative 8. Okay, now I'm going to do the process of completing the square. Actually, I'm going to spread this out a little bit, give myself a little extra room. Okay, so remember what my process was is, okay, I look, is there a coefficient there? No, there isn't. Yay, I'm good. There's no negative and there's no number. We're good. So then I look at the number next to the plain x. First, I divide it by 2. That gives me 3. Then I square that number. That gives me 9. And I write it there, plus 9. But in algebra, we can't just add something to one side of an equation without adding it to the other. So that's what we do. We add it to both sides. All right, so on the left, I have turned this first x squared plus 6x, I've turned it into a perfect square. Well, what perfect square is it? Here's what it is. X is always going to be your first term. Always. You'll see why in a second, because we're going to get rid of, if there's a coefficient there, we're going to get rid of it. So it's always just x. And then this step right here where you take this, in this case positive 6, and you divide by 2, whatever you get is what you put down here. So in this case, positive 6, why isn't it undoing? There we go. Positive 6 divided by 2 is positive 3. And that's what it is. On the right, we have negative 8 plus 9 is positive 1. So to solve this, Now we just have x plus 3 squared equals 1. If we want to figure out what x is, we need to undo what's been done to x. So I'm going to take the square root of both sides. On the left, that gives me x plus 3. On the right, the square root of 1 is positive or negative. That's crucial. Don't forget that every time we do square roots, positive or negative. Positive or negative 1. So then I split those up. What is x if x plus 3 equals positive 1? What is x if x plus 3 equals negative 1? So on this side, I subtract 3 from both sides. X equals negative 2. Over here, I subtract 3 from both sides. X equals negative 4. And that's it. I've solved it. Okay, now again, that could have been done with factoring. Not all of these are. Some of them are a little stranger. And that's actually why difference of squares, completing the square can be useful. Because you go, okay, well, I can't factor that. Like, what multiplies to 23? 23 and 1? Like, it doesn't work. All right, so what's our steps again? First, we put the lone number without an x over on the right-hand side. We do that by doing the opposite. It's being added, so we're going to subtract 23 from both sides. That will get it to cancel out. On the left side, I am left with x squared minus 12x. I'm going to leave a little gap. On the right, I have negative 23. So, what are my little steps? Because I don't have a coefficient in front of the x, I can move on to the next step. Negative 12, I divide that by 2, and that gives me negative 6. I can also go ahead and write negative 6 in my little in what I'm squaring. And then to get my second term, I take that negative 6 and I square it. That gives me positive 36. So positive 36. I need to do the same thing to both sides. All right, so on the left, I've turned x squared minus 12x plus 36 into x minus 6 squared. Or actually, technically, I've turned x squared minus 12x into x minus 6 squared. And on the right, negative 23 plus 36 is positive 13. All right, so now to solve for this same thing, I take the square root of both sides, and I get x minus 6 equals positive or negative square root of 13. You're like, ugh, that doesn't look very nice. Yeah, well, that's what you get sometimes in math. You get things that don't look very nice. Okay, so I'm going to split that up into x minus 6 equals positive square root of 13, and x minus 6 equals negative square root of 13. Add 6. X equals 6 plus square root of 13. Same on this side, add 6. X equals 6 minus square root of 13. And those are my two answers. All right, the last variation of this is when you have a coefficient in front of the x. Okay, in this case, 6x squared plus 12x minus 48. The first thing you want to do, and I mean this without exception, the first thing, if there is a 1, I mean, there's not a 1, if it's not a 1, if there is a 2, 3, 4, 5, a million, if there is a negative, even if it's just a negative x squared, then you want to pull out a negative 1. You do not want anything in front of that x squared, no negative sign, no coefficient. The absolute first thing you're going to do is divide everything by whatever's in front of the x squared. That's it. If it's a negative, like say if this was like negative x squared plus 5x plus 3, I don't know. First thing you do, divide everything by a negative 1, so it'll just change the sign. This is critical. You have to do this. And you do this, in this case up here, in this one, it's going to turn out nice and pretty. So 6x squared divided by 6 is x squared. 12x divided by 6 is 2x. Negative 48 divided by 6 is negative 8. 0 divided by 6 is 0. Hey, nice and pretty, and then you go on doing your complete the square like we just did. However, it doesn't always turn out nice and pretty. Sometimes your textbook or your teacher will be mean, and you'll get some not so nice things. And you're like, but I'm going to get fractions. I know. Got to do it anyway. And then you got to go from there. Even if that happens, even if you're like, but 6 doesn't come out, or 3 or whatever the number is, it doesn't come out cleanly. Doesn't matter. You have to take it out. And here in this case, as you can see, you're back to being the more normal completing the square situation. Little side note here, if you are doing something with a fraction, same thing applies. Like if I go to the next step on this one and I do what I'm supposed to, and I get the 14/6 over there on its side, on the right side. Same process. Even though I know it seems silly, you divide by 2. 10/6 divided by 2 is 5/6. So I'm creating x plus 5/6 squared. And then the next step is I take 5/6 and I square it, which is 5/6, and that's hard to say, times 5/6. 5 times 5 is 25. 6 times 6 is 36. And you complete the square, and again, you add the same on both sides. I know that's really awkward, and that's a pain when fractions get involved like that, but it does happen. It absolutely happens. Okay, so that is completing the square. If you have any questions, again, if it's something about using completing the square in vertex form for quadratics, please go to the other video because there's some subtle differences, some little changes in how you do it. The same underlying principle is still there, but there are some changes. Please go to that video if that's what you are doing. If you have any questions or specific things that you'd like to see in future videos, or just different topics you'd like to see in future videos, please leave a comment down below. It is much appreciated. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.